Determine where the curve, whose x and y coordinates are given by cosine 4t and t cosine 3t, and we're only looking for parameter values between negative pi by 4 and pi by 4. Obviously, you could enter larger or different t values in here, but the curve is being restricted, so we're only drawing so much, we're only working with so much of the curve. Okay? So determine where this intersects itself. But we are being told it intersects itself. Okay? And what does that mean? We get the same point on the curve, but for different values of t. And, when you think of intersections, you think of something like a loop like this, but you can technically have intersections if the curve just goes up to a point, stops, and comes back on itself. Okay? In which case you get lots of points. If you have just a pair of points, but everything in between is all separate, that's when you really get a loop. Okay? We're not talking about loops or anything like that, but it's important to keep in mind. Okay? So how do we tell if a curve intersects itself? Well, we use the same basic setup whether or not two curves intersect each other. Okay? At the point of intersection, the curves will both have the same x-coordinate and the same y-coordinate. Okay? But here we're using the same curve. So what we'll do is we're going to set up equations equating the x and y coordinates, but rather than always having this t in here, we're going to introduce some new parameter s. Okay? We're going to ask that s not be t, and we're also going to be working with s and t confined to our particular range of values between negative pi by 4 and pi by 4. Okay? We need to make sure the x coordinates are equal. So we need cosine of 4t to be the same as cosine of 4s. Okay, and then t cosine 3t needs to be the same as s cosine 3s. Alright, and now what we need to do is just sort of solve. Can we find t and s that are different that make these equations equal? Okay, that satisfy these equations. Because, of course, if you use the same s and the same t, since we're really looking at the same equations, you'd get satisfaction there. You'd get true statements. So what should we focus on? We might be tempted to try and rearrange the bottom equation a little bit. But I find solving polynomials mixed with trigonometric functions kind of hard, so I wouldn't recommend that. You might be able to find some sort of trig identity to help, but it's a lot easier to just look at the first one. Cosine of 4t has to be equal to cosine 4s. Right, so let's focus in on that. What we're asking here is for the cosine function. Well, technically, I guess you could say cosine 4x. We're asking for the graph of this to hit the same value. Okay? And ordinarily, we wouldn't care because, of course, cosine's going to hit the same value. Cosine just keeps going on and on, always runs through the same stuff, but we're kind of limited where we're looking. Okay? So let me sort of say something like this. If we're only looking for values that are between negative pi by 4 and pi by 4, that means that 4 times our parameter is going to be between negative pi and pi. What does cosine look like from negative pi to pi? Okay, so 0 here, and maybe pi by 2, and then negative pi there. Okay, it looks a little something like this. Okay, we get negative 1 here at negative pi, we get negative 1 here down at pi. Okay, and you remember, oh, cosine is an even function, so there's a nice degree of symmetry. But I can also see, just by sort of sketching some horizontal lines on my curve, that the only way you're going to get the same value, the same output, the same y value represented by these horizontal lines, is if you pick one value and it's negative. Okay? So what we can sort of reason by just looking at this graph here is that when you're restricted to going between negative pi by 4 and pi by 4, cosine 4t and cosine 4s can only be equal if t and s are equal, or t and s are opposite in sign. And of course you get both of these if you're working with 0, so we'll have to ignore 0 if it comes up. Okay? We don't want t and s to be the same, so let's take a look now at t and minus s being the same value in our second equation. Okay? So t cos 3t needs to be the same as s cos 3s. That way we get the same y-coordinate, but for different parameter values, s and t. Okay? But well, s is negative t there. They're opposite each other. So we can replace all these s's with negative t. Okay? But notice something else. Cosine, again, is even. Okay? You put in a negative value, like negative 3t, it's the same as the positive value. Okay? Cosine doesn't care about minus signs inside. Okay? And this is a lot easier to work with. Add t cos 3t to both sides. Okay? And we see that either t is 0, which we already sort of commented isn't going to work because then s will be 0, and they'll both be the same value. Or cosine 3t is equal to 0. Okay. Now we're going between negative pi by 4 and pi by 4, so 3t is between 3 pi by 4 and negative 3 pi by 4. When is cosine equal to 0 in this sort of range? Well, cosine is equal to 0, and this is between negative pi and pi, so definitely within the range we're talking about. It only happens at negative pi by 2 and pi by 2. Oh, sure, it happens out here at like 3 pi by 2, but that's well beyond the scope of what we're talking about. So 3t is going to either be pi by 2 or negative pi by 2. And that means t is either pi by 6 or negative pi by 6. And if t is pi by 6, then s would be negative pi by 6. If t is negative pi by 6, s would have to be pi by 6. Okay. So we get the same xy point when t is pi by 6 and our parameters negative pi by 6. Those two will yield the same point. But they didn't just ask, what parameter value or does itself intersect. They said where. So we should work out this point. Okay? And it'll be the same point, but if you want to, you can sort of double check that we did do the right work. I'm going to just plug in pi by 6, but make sure that I'm not lying and that minus pi by 6 will also work. And then t cosine 3t. So this is our xy point that we're interested in. So cosine of 2 pi by 3 is minus 1/2. And we'll get pi by 6 times cosine pi by 2, which is 0. Okay. So the curve intersects itself. Only at t equals pi by 6, negative pi by 6, at the point, negative 1/2, 0.